Hello and welcome back. This is part 2 of the tutorial on combining multiple simulators into one continuous ocean surface and creating a swimming pool using several independent simulations. In the first part, I showed you how to choose which simulation grid to use as a source for the material and displacement using MaxScript, identify what needs to be done, and what to watch for to ensure the ocean surface connects seamlessly. Trim unnecessary sections of the ocean surface using the V-Ray clipper. I also explained the benefits and drawbacks of this method, including limitations like potential errors from overlapping grids and the lack of interaction between the separate simulations. In the second part of the tutorial, we'll explore how to use the cascading simulation option inside Phoenix to avoid discrepancies in water levels across different grids, and how to pour water from separate simulators into one common pool at the bottom. Right, let's get started. Okay, here's the original scene with just this one single simulation. If you haven't watched the first part of this video, you can do this now and see how to make this, step by step. Here's the Phoenix simulation grid. Also, the source node that uses this box as an emitter. It's this one, box 001. Inside the source, there's the box. And down here, I have the emission polygon ID set to 2. That's the one polygon at the back of the object. Right, all of the other polygons are set to ID 1, and this one here is set to 2. Okay, so that's pretty much all there is. For the grid settings, I have the initial liquid fill set to 15%, and I also have the fill up for ocean enabled. This prevents the water from spilling to the sides, even though the walls of the container grid are left open. The ocean fill acts as an endless ocean volume that doesn't have a bottom. When rendered, the ocean mesh rendering mode extends the surface all the way to the horizon. I think I might have mentioned this in the first part of the video, but let me remind you, there's another video on this channel that explores the ocean fill option in more detail. It is called Initial Liquid Fill for Fountains and Rivers. You can watch it if you're interested to know more about it. When you make a copy of this simulation, and you can make as many copies as you want, the ocean surfaces will merge seamlessly, provided that the levels match, and you are rendering this inside 3D Studio Max. If the surface level isn't the same, actually, let me quickly show you this. I'll delete one of these simulation grids, leaving just these two. I'll move the source helper and the emitter object up. I'll adjust the second grid's height, say 230 voxels on the z-axis. I can start the simulation now, but since I copied the second sim, both of them now point to the same cached sequence. I don't want to overwrite it, so let me quickly go into the output or rollout and reset the output paths to their default value. I'll do this for both simulation grids. It won't affect the original grid. It'll still find the cache sequence that it exported. The copy, though, will search for a cached sequence that doesn't exist yet. Let's simulate it. Seems like there is some liquid at the bottom created by the ocean fill, but the emitter isn't emitting anything. That's because when I copied the source node, Phoenix disconnected it from the first object, but didn't connect it to the new one. Let's stop the sim and fix this. Select the source helper and add the second box as an emitter object. Right, let's try that again. And now we have two separate independent simulations. I'll stop this one at frame 50. I think that's more than enough for now. Right, both of these are filled at 15%. But if I render this, it is obvious that the water level inside the right one is higher than the water level in the left one. You need to move one of them and try to match the level like I showed you in the first video, or perhaps adjust the level percentage. But let's see how we can separate the water level into its own simulation grid and make sure it will always stay consistent. Select the first grid and disable the initial liquid fill. Before I forget, I'll go into the rendering rollout and set the meshing mode to a regular mesh. This will disable the level percentage options. I'll start a new simulation. It looks the same, except there's no liquid at the bottom anymore. The taller grid just reads the cached files at the moment. It isn't simulating. Okay, In the new simulation, some splash particles are leaving the grid. There's no liquid at the bottom anymore to absorb them, so they just fall down. And let me just pause for a moment and say a few words about this. Right, you can see that the splash particles are leaving the simulation grid and they keep going. And that's because the splash particles are allowed to live outside of the grid. That is also true for the other types of secondary particles, the foam and the mist. These are the types of particles that are allowed to live outside the simulation boundaries. The liquid and the wet map particles, on the other hand, are not allowed to do that. Once the splash, foam, and mist particles leave the grid, though, they won't be able to interact with any objects. They won't collide with anything. They just become sort of dumb points that just fall down. Let me create a box here real quick. Like this. Right, move it a bit down. Let me put it into a new layer. I'll just set it to display as a box so I can see what's going on the inside. Let's restart the sim. Maybe move this a little bit. Right, you can see that the splashes will go right through and not interact with that box in any way. Even if I open the Phoenix Properties dialog, enable the Clear Inside option, there's a list of all the different channels that should be deleted once they are inside the box. I can add the splash particles here. Okay, but nothing will change because Phoenix doesn't know about anything that is outside of the simulation grid. If I move the box up here, well, first of all of the particles will start colliding with it since it is a solid object. I can open the properties once again. Set the object to non-solid. Let me restart the sim so we can see the result more clearly. Right, so now the liquid and the splashes are deleted or cleared when they enter the box volume. The foam apparently goes through since it is not on the list. I can add it, of course. Separate the entries with a comma. And let's, for example, remove the liquid. Okay. Now, the liquid particles will pass through the non-solid object, and the splash and foam particles will be deleted. If I move the object outside of the grid again, the splashes will go right through it as if it isn't there at all. And as far as Phoenix is concerned, it isn't. It is outside of the grid, so Phoenix doesn't have a clue about its existence. I wanted to demonstrate this because you'll be surprised how many people are asking about this, myself included. The other day, I tried to make a kill box to get rid of some splashes that were flying away. And I was like, oh, right, it doesn't work that way. I remember that in RealFlow, there is maybe a dedicated node for this. Maybe you can use this technique in TyFlow. Phoenix, however, has its own way of dealing with this by limiting the lifespan of these stray particles. Inside the splash mist rollout, there's a max outside age parameter. The default is 10 seconds. If you set it to 0, they will be deleted right away. There's a maximum outside age for the foam particles as well. And yeah, as I said, a few people asked me about this recently, so I decided to take a moment and try to clarify this. Right? For what I'm making right now, I don't actually need the foam, so I'll turn it off. I'll restart the sim and wait for it to finish. Okay, let's go back to our setup. With the splash and foam leaving the grid taken care of, that's how the simulation looks. So let me get rid of this other grid. Right, this is what we have now. I can create a new simulation grid down here at the bottom. And here's something interesting. Since the new grid has the same name as the one that I just deleted, upon creation, Max named it Phoenix FD Liquid 005, and it loaded these 50 frames that we simulated with the grid that I just deleted, which had the same name. This happens in Phoenix when using the default scene path macro. I made a video not long ago explaining in detail how those macros work. I'll leave a link in the description if you want to check it out. Okay, if I run a simulation now, it will overwrite those files and replace them with new ones. But I'll just delete it just in case. Right, the grid is now empty. I'll align it with the other one. And let's set it up. I'll first check the size. It's 57 voxels. I think 40 might be enough. I'll enable the initial fill here. The default 50% might be okay. And in the grid rollout, I'll enable the Cascade simulator options, and I'll pick the other grid, the first one, as a source. I'll start the sim. When you cascade simulators, the particles inside the previous cascade are transferred into the new one. That's what it does. Currently, it transfers only the liquid particles, but not the splashes or the foam. If I want to transfer the foam, for example, I need to enable it inside the second grid. Let's do that. Phoenix asks if we wanted to create a particle shader for us. I'll say no because I already have some shaders inside this scene. We'll take a look at them later. With the foam enabled for the second cascade, all of the foam particles potentially coming from the first one will be transferred. However, I don't have foam particles inside the first cascade because I disabled it, right? However, the incoming liquid hits the water surface, disturbs it, and creates new ones. You can control the amount of foam bubbles being spawned, or the threshold. And you can also control the lifespan of the foam bubbles that are on the surface. By default, it's 10 seconds. I can reduce it a lot. Say 0.3 seconds. This might affect all of the existing foam bubbles, or it could affect only the new ones spawned after I changed the value. I'm actually not sure, and I need to check this. Anyway, I'll just restart the sim to make sure that all of them are affected. Right, there's this preview option called Auto Scale Color that shows the fastest moving particles in white. Usually it's very convenient, but in this case, it might be a little confusing, so I'll switch it off. Right now, only the falling liquid particles that have a velocity above 200 will be shown in white, but not the rest of them. And the threshold above which this is happening will be fixed and won't change. The simulation was done in about 2.5 minutes. It seems fine to me. Let me once again make copies of these two grids, along with the source node and the emitter geometry. Phoenix will change the output paths again, making sure that they point to the relevant caches. But I want to make new simulations, so I'll change them back. Now I'll move the emitter up. And I'll make this grid higher, like this. And again, I forgot to add the geometry into the source node. Let me do that and try this again. Perfect. Okay, 50 frames are enough. Before I simulate the bottom part, and I'll just check which grid will be used as a cascade source. Seems like 006 is the correct one, right? Yeah, the other one was using 004. I'll simulate 50 frames for this one. And now those two that are at the bottom will be the ones that are going to be connected. But, of course, I need to set the meshing mode to ocean mesh. I'll render this. The first grid with an ocean mesh enabled will be used as a source for the materials and displacement settings. And there it is. There's no material and no displacement map now, so it will use the default blue color and the surface will be flat. But when I add them, I need to add them to this one, and they will be used for the entire surface. The displacement map also goes into the first ocean surface. Enable it and add the map into the slot. In the first part of this video, there is a more extensive explanation of how Phoenix determines which simulator has the highest ocean priority and will be used as a source for these settings. If you missed it, you can go back and watch it. Let's now move on. This is another setup that uses this technique, but what do we gain by separating the individual parts into separate simulations? Well, besides keeping the bottom parts at the same height and making sure that the water level matches, this also optimizes the grid sizes and potentially speeds up your simulations. There's no need to simulate empty voxels down here. Here as well. And in this example, there are 3 separate cascades. You can link as many as you like. In this scene, there are other elements. These smaller waterfalls. These are not separated into cascades. You don't have to do this for every simulation, just for the ones that make sense. Let me unhide the shaders, also the clippers, and the pool geometry. This is how it looks when rendered. And I have one more simulation here that I forgot to unhide. And this is what the rendered sequence looks like. I will upload the scene for you to download and examine if you like. There will be a link in the description. So let's recap what we achieved by separating the sim into cascades. We can have elements with different heights, but at the same time have elements at the bottom that will always match. However, you'll still have issues when the ocean surface elements overlap. For example, if I move this one over here, when rendered, you'll get some meshing errors. There's this dark area here. It might be a little hard to notice. Let me try to put the camera higher. Yep, there it is. This could be double faces or something like that. I don't really know. The meshing happens on render time, so there isn't a way to inspect the geometry. But it doesn't look right, that's for sure. I'll also move this one here. Actually, let me grab all of the elements, like this. Yeah, not good. But what if we want to bring these two waterfalls closer together? We can't really do that, can we? It'll break the surface. So, can we just use one single simulation at the bottom? Sure. Let me delete this one. Move the other one in the middle. Make it wider on the y-axis. Okay, but here's the thing. Now it uses the first waterfall, the one called 001, as a cascade source, and we can't pick more than one source. So the question is, can we fake this somehow? Can we do this without using the cascade option? Let's clear this up and disable the cascading checkbox for the simulation down here. So will this be able to interact with these other 2 simulation grids? Let's try it out. Right, the cascade is disabled. Let's press start and see. It looks like there's some interaction, which is great. So when we were using the cascaded option, the liquid from the source cascade was transferring some of the particles into the new grid, and they were hitting the water surface, creating some foam. However, when you are using an ocean fill, you won't end up having more water inside the grid. The ocean level stays constant. It doesn't have a bottom, and it stretches to the sides. So pouring more liquid into it using a cascade won't change anything, really. We were just using these added particles to have some interaction between the two sims. Seems like there's some interaction by default, though. So let's look into that. Let's see what it is interacting with. Let me pick this one. Go into the preview settings and show the mesh. That's what's happening. Even though the mesh was hidden from the viewport and you can't see it, when the containers overlap, Phoenix still builds the mesh, so it can be used as a collider. And of course, this will take some time, depending on the resolution, and will slow down the simulation slightly. But you have a solid object hitting the water's surface, and some interaction as a consequence. Let's stop this for a second. Let's go into the preview settings for the grid at the bottom. Hide the particles. Maybe look at it from the side. Preview just a slice across the y-axis. Enable the velocity preview. Right, there it is. Might be a little hard to see, so let's choose a brighter color and adjust the preview range a bit. Okay, you can see that some of the arrows are pointing toward the mesh. So even though the mesh isn't moving, it's a static mesh that regenerates on each frame. There's some velocity information used for motion blur and whatnot. Let me try making this more visible. Maybe make the slice wider. Yeah, you can see what the velocity channel looks like. In reality, the water that falls from above won't just go through like it is happening at the moment, but it will swirl and maybe push the volume that's on the bottom away from the falling stream. Oh, this slice is in the wrong place. Let me move it under one of the streams. Yeah, I think you can see it more clearly now. It doesn't look that bad. It made some swirls and everything. But the foam isn't spreading very much to the sides. It's just forming where the mesh is colliding with the surface. And if I open the Phoenix properties for those two waterfalls and make these two meshes non-solid objects, okay, and restart the sim, you can see that there's no longer any interaction between these. They are completely ignored. So let's try to fix this. I'll create a new Phoenix liquid source, and I'll add the liquid particles as emitters. The particles will be 1 voxel wide. And I don't want them to emit any liquid. I will just make them inject some outward force. Just a little bit. Maybe 0.5 will be enough. Right, let's try this again. Looks like it's working. Let's also add the liquid particles from the other grid. And you can also add the splashes if you want. You can add the splashes from the first one as well. Let's see what we have. The simulation is currently paused. I can resume it. But you know what? Let's start this from the beginning. Stop and restart from frame 1. Okay, so now you have these two interacting with the same container. It creates a foam that spreads out and the water bubbles can bump into each other. And that's what we were trying to do, right? The simulation was done in about 6.5 minutes. Let me bring these two even closer together and simulate the one at the bottom again. I'll wait for another 6, 7 minutes. That's okay. By the way, you can switch the two waterfall grids back to solid objects, so the mesh can be picked as a collider again. And since you are using the particles as emitters, and not the mesh itself, you won't get the warning that the volume inject mode needs a non-solid object. Particles are always non-solid, right? Also, if you want to have a stronger impact here on the surface, you can increase the inject power. So now it's only a matter of tweaking some settings to get the look right. You can adjust the lifespan of the foam bubbles. Make it live longer, for example. It's better if you keep the lifespan shorter because, in reality, the bubbles burst really quickly once they pop on the surface. If it is water, not soap water, or some other oily or greasy liquid. But I'm trying to make these bubbles spread out and bump into each other and form some patterns. Speaking of patterns, you can increase the pattern formation speed. Yeah, these are really nice. So, in addition to having a foam created by two separate sources interacting, you also have the convenience of having to tweak these settings in just one place. Okay, before I wrap up this video, there's something that I want to show you. Here's a scene built out of individual elements, using the same techniques I just showed you. It's a dancing fountain scene, I believe it is called. I made this because a guy on Facebook contacted me. He reached out and asked if this is even possible to achieve with Phoenix. And I said, well, I've never done anything like this before. There's not that much of a fluid motion here. And this, by the way, is the reference that he showed me. I said, this might be doable with Tyflow as well, but if you know Phoenix and want to use Phoenix, a smart thing to do might be to split all of the elements into separate simulations. You'll have more control and the project will be more manageable. So I did some initial tests just as proof of concept, a little bit of R&D, and this was the result. I can isolate different elements. For example, I have just a simple simulation of one single arch here, and it's distributed in a radial array. And all of the copies are reading the same cached sequence. But these are individual Phoenix grids. Here's the original one that I used for the simulation. Also the dancing elements. There are 2 rows of them, but again, these are just individual copies. They start playing this one sequence at different times. There's a timeline offset set for each one. For example, this one starts at frame 3. The next one starts at frame 6. The next one at frame 9, and so on. And at some point, I wrote a simple for loop for him, where he can offset the play at value incrementally with a chosen number of frames. I can't upload this exact scene, but perhaps in the future I'll record a more detailed breakdown. You can subscribe to this channel if you want to be notified. So yeah, it was a crazy plan to have that many grids in one scene. But it worked out just fine. At some point, he sent me this video showing the final result. I won't play the entire video because I'm not sure it's appropriate. But yeah, job well done, I guess. Alright, that's it from me. Don't be shy to comment. If you liked the video, please press the button. Take care, everyone, and goodbye.